Going on now to topic 3 of chapter 1. We'll be dealing with fractions and mixed numbers. Our objectives: write fractions in simplest form, multiply and then divide fractions, add and subtract fractions, and then perform operations on mixed numbers. Now, even looking at some of the vocabulary here, there may be some things you don't know, but that's what we'll go over in the lesson. Now, to start us off, to give you an idea, which is sort of a joke, on what fractions are all about. Now, when we look at fractions, sometimes we wonder, well, what's the big deal about fractions? Well, we have this story about Yogi Berra, who was a catcher for a famous baseball team and became a sports caster. And he would say some interesting things. And these things he would say are called yogiisms. Well, he would go into Tony's pizza parlor every Friday evening, and he would order a pizza. Now, Tony's pizza only had one size. So he said to Tony, he says, tonight, just cut it up into 4 pieces. Now, Tony would usually cut it up into 8 pieces. And when Tony said, how come? He says, well, I'm not too hungry tonight. And I don't know if you get the concept of that sort of a joke, but it's dealing with fractions. That in this case, he was eating the same amount of pizza. It's just that they was dividing that same amount into more equal pieces. So that in one case, 1 here, was it equal to 1 there? And the answer is no. So when we develop fractions, a fraction is actually a ratio, which is a comparison of the number of parts you are dealing with out of the number of parts there are. So in this case, it was 1 out of 4. In this case, it was 1 out of 8. And in a sense, these ones are not equal. So in dealing with fractions, the key to it is, how many pieces do you have? Here we have 4. Here we have 8. So in order to get the 4 to equal the 8, we are allowed, as I mentioned earlier, to multiply anything by 1. 1 over 1. But our 1 in this case is going to be in the form of 2 over 2. So that then this would become 2/8. That 1 there is actually 2 out of 8. So a little background in equivalent fractions, how to get them, but we'll take a look at our lesson and get started. So the first thing they'd like us to do is to simplify by dividing the numerator, which is the upper part of the ratio or fraction, by the denominator, which is the bottom part. So 3 goes into 3 once. And we say anything divided by itself, as long as it's not 0, is a 1. 4 will go into 40 10 times. Now, we don't put it 10 over 1 or 1 over 1, but generally we assume that there is a 1 under any whole number. Now again, this is what they're showing here. This is just 16. But in a sense, it's 16 over 1. We don't write that. Now here's a special case where there's nothing over the 7. So anytime we have a 0 in the numerator, the upper part, divided by a number that's not 0, the answer is 0. And here's a real special case that when you have a number in the numerator that's not 0, and it's divided by a 0, in our mathematical system, we don't have a definition for this. That is, a number other than 0 divided by 0. So we say this arrangement is undefined. Okay, so you'll have more examples in your practice, and then later your quiz me. All right, example 2. Write each fraction as an equivalent fraction with the given denominator. So let me write some of these up here for you. And again, you're taking notes on this. And this is a strategy how to set it up. So there's our fraction, and we want that to be equal to a fraction that has a denominator of 40. So the trick here is, what do I need to multiply 10 by to make it a 40? And you're going to say 4. Now I'm allowed to multiply this fraction by 1. And since I know I need a 4 in the bottom, the one I'm going to choose will be 4 over 4. So now my numerator becomes a 12. And 12/40ths is an equivalent fraction. We multiplied it by 1 in the form of 4 over 4. Okay, let's do another here. Clear it up. We have 4 sevenths, and we want a denominator of 56. So think about this for a moment. We're going to multiply this by a 1 in the form of, yes, I had my wife ask me a question here, so I got interrupted a little bit. So again, we're wondering, what do we multiply this by? Some form of 1 to make our denominator 56. So it'll be 8 over 8. So 4 times 8 is 32. And 7 times 8 is 56. So that is that one. Now in this next part, we're asked to simplify fractions. And this is taking out any common factors of 1. And let's factor this. This is 1 times 5. And this is 2 times 5. So the 5's make up a 1. So this simplifies to 1/2. Now in letter B, this is going to be 3 times 3. And we're looking again for common factors. So I see a 3 times 5 here. So again, our 3's cancel out as a 1. This is sort of the reverse of what we did up here. So our answer then is 3/5 when we simplify. Now for this one, you might see 8 times 11 and 6 times 11. So the 11's would make a 1, but we can also factor out through canceling a 2 out of each one of these. 2 goes into there 4 times, 2 goes into there 3 times, so letter C is 4/3 simplified. Theoretically, I could have taken a 22 out of each one. Now, when a number ends with a 0, we can just divide out a 10, and then we're left with a 30 over 55, which is 6 times 5 and 11 times 5. So again, the 5's are 1. So our simplified answer of this is 6/11. Now, when we multiply, the rule is you can multiply the numerators, you can multiply the denominators, and that's your answer. But before you do that, you should carefully check to see if you can cancel anything out, as we did up here. That makes your numbers smaller and leads to better accuracy. So nothing cancels out here. So we get 5/21. And if nothing canceled out here, then nothing would cancel out there. Now for this one, we see we can do some cross-canceling. 2, for instance. 2 will go into 6 3 times, into 8 4 times. 3 goes into 21 7 times. And, well, let's try it different. 7 is going to go into there, actually, 3 times. 7 will go into there 4 times. There we go. So 4 times 4 is 16. 3 times 3 is 9. Now, since we canceled here, and there's nothing else that will cancel, when we get our answer, we don't have to worry about simplifying it anymore. Now, in this case, this is sort of critical, and I'll clear it up. We're going to have a division of fractions. When we divide fractions, there's a certain rule, 6/19. Now the rule is we convert our division to multiplication, and then in so doing it, to keep it accurate, we have to flip this, and it becomes 13/9. And this is where I had to insert something. Let me double check letter C with you. Again, we're going to cancel out a common 3, get a 2. A common 3 out of 9 and get a 3. Here we can't cancel. And this is 2 times 13 is 26. 3 times 19 is 57. And we may have shown that right here. And the key of multiplication We just divide our numerator. Well, we multiply our numerators and denominators, canceling out wherever we can. In division, though, we have to change it to multiplication by flipping, taking the reciprocal of the second term. And then for letter D, another one, 9/14. So I'm going to change that to multiplication, flip that, and cancel wherever I can. 3 goes into 9 3 times, 2, 3 once, 2 goes into there 5, into there 7. Again, it was division. I changed it to multiplication and flipped the second one. So critical. And then you get 15/7. Okay, now we're moving on to subtraction of fractions and addition of fractions, but in some cases they may not be the same denominator. Now, as we mentioned in the very beginning, we have to have the same denominator in order to really evaluate what's in the numerator. So our general rule is these are the same denominators, so we just put that there. And then we put our numerators over a common division bar. And this will give us then 4/8, which can be reduced to 1/2 by canceling out a 4 from each one of these. So here's where we get started. Again, hopefully I'm going over strategy for doing these. Now, for something like this, we have to determine what is a common denominator of 6 and 15. Well, if you just multiplied them together, that would give you one, but that'd be a very large number. But we know we might go for 30, for instance, because 6 times 5 is 30, and 2 times 15 is 30. 30 is what we'll go with. That's the least common denominator. So we're going to multiply 6 by something, a 1, in the form of something that will give us a 30. And that will be 5/5. So our numerator then becomes a 5, and our denominator becomes a 30. And there's a plus right there. Now, what do we have to multiply 15 by to make it 30? 2. So it'll be a 1 in the form of 2/2. So this makes our denominator 30 and our numerator 14. We now have a common denominator. We just add our numerator and we get 19/30. And there it is right there as well. Okay, now we'll do some subtraction. Again, we're looking for a common denominator, and we're looking for a strategy to do it. So 9 and 12. And again, if you know your multiplication tables, that helps. Well, 9 times 4 is 36, and 3 times 12 is 36, so looks like 36 here. So we're going to multiply this by a 4, which is a 1. So that'll give me here a 20. 12 we're going to multiply by a 1 in the form of 3/3. This gives me a 36. Don't forget there's a negative sign there. And that's going to be 1 times 3 is 3. So now we have our common denominator. We're going to subtract these, and we get 17/36. 17/36 right there. Okay, this next one, remember anytime you want to go back, you can. We're looking for strategy. What will be our common denominator here? Let me give you a moment to reflect on that. Remember, you can always pause the tape. 24, if you said, is correct. Because 8 times 3, multiplying this by 1, in the form of that gives me a 21. Minus, what is the form of 1 we're going to use here? If you said 4 over 4, that is correct. So this becomes 1 over 24. We are on number 5. There it is right there. Okay, now this next part's a little tricky, and there are a couple of ways to do them. But I'll feature one way, and then if you are familiar with a way you like too, you can use that. Now, here's how I would do letter A. I'll set it up for you. Now, I paused the tape so I could just write this out, save a little time. But I just copied this. I'm going to check I copied it correctly. Yes, and it's addition. Now, what I need to do is add these fractions. And I'm sort of doing it vertically. This is how you may have done it in elementary school or junior high. What's your common denominator between a 3 and an 8? 24. Well, let's write that correctly there. So, 3 times what is 24? 8. 2 times 8 is 16. 8 times what is 24? 3. 5 times 3 is 15. So I now get 31/24 from this, adding this up. Now, I want to end up with a number in which, where this is an improper fraction, I want it to be a proper fraction. So how many times does 24 go into 31? Goes into there once, and it has 7 remainder. So when I added these two fractions, getting equivalent fractions, getting an improper fraction, I now have a mixed number. So when I add these two together, I get a 19, but I have this 1 here as well. So that's going to make it 20. 19 and this 1 makes it 20, and then this is 7/24. So 20 and 7. Oh, I see they have a little error here. That should have been a 4. 8 and 3 is 24. Okay. And we copied it correctly. Every once in a while, you will find a little error there. Not a big deal. All right, let's do letter B. Let me set it up for you. So there it is. 5 minus this. Now, notice there isn't anything up here. So what I have to do is borrow 1 from the 5. That'll make that a 4. And then it's like 4 plus 1 here. But I'm going to put that 1 in the form of 7/7. So 1 is 7/7 that I'm borrowing from the 5. Now, 3 from 7 is 4 sevens, they're common denominators, and a negative 2 from 4 is a 2. And that's how I do that one. Okay, we're going to do a multiplication now. Well, to start us off, I need to convert these mixed numbers, a whole number and a fraction, to an improper fraction. So I take my denominator, multiply the whole number, get 6, add 1 to it, get 7, 7 over 3. This is the mixed number. This is the improper fraction. It's just multiplication. 7 times 6 is 42, plus 3 is 45, again, over 7. And nicely, notice what happens here. 7 will cancel there with this 7. 3 goes into there nicely. 3 times 15 is 45. So my answer here is just 15. Should be letter C here. Let me check that. Yes, I was looking at number 5, and of course it doesn't match up over there. All right, you have to be a little tricky here. All right, going on to our last one here, and let me set that one up, or I'll do it with you here. We have a few moments. So 5 times 3 is 15, plus 4, 19 fifths. I'm going to change that to multiplication, because it's division. 5 times 1 is 6. 5 times 1 is 5, and 2 is 7 fifths that I have to take the reciprocal of. So I have to flip it. Now, the 5s cancel out, and I'm left with 19 sevenths. 19 sevenths is good. Okay, so it says some students may need visual review of meaning of fractions. I gave you that little joke here, the thing in the beginning. Most students have experience with fractions but have forgotten the procedure. So we went over adding and subtracting fractions with the same denominator, with different denominators, and stressed that all fractions must be written in simplified form. Now, if you don't simplify them, Math Lab will count them wrong. Okay, so just 23 minutes, not too bad.